Good morning, students. Our today's topic in the subject of chemistry is limiting reactants. So this is again very important topic, a technical one. A lot of concepts will be used in this topic. Apparently tough one, but if you concentrate, I guarantee you this is much easier topic. So concentrate yourself. We are going to start a limiting reactant or limiting reagent, the reactant that is completely consumed in a reaction. The reaction stops as soon as the limiting reactant is totally consumed. So definitely one of the reactant will be consumed, so reaction will be stopped. The limiting reactant limits the amount of the product formed, because after that reaction will be stopped and no more products will be formed. So limiting reactant limits the amount of the product formed. Check for the limiting reactant when the quantities of the two or more reactants are given. Okay, students, I'm first giving you a brief sketch of this topic. Again, you have to take grip on balancing the equation first, because that will be the first step in the question. You have to write down the balance equation. So practice a lot at your home of balancing the equation, because in the paper we will not have much time to think about what will be the products, what will be the reactants, and then balancing the equation. So you must have enough practice to write the equation as quickly as possible in the exam. So this will be the first step. Write the balanced equation for the data. Next step will be, then you have to decide which one is the limiting reactant. Okay, for deciding the limiting reactant, there are two methods. So first, we are going to solve the question through the first method. So concentrate yourself. Both methods are easy and interesting. So look now, our question is, a mixture of the 10 moles of hydrogen and 8 moles of the oxygen was made to react according to the following equation. In this question, this is easy now because the equation is given. Okay, look now, moles of the hydrogen and moles of the oxygen are given. So first step is, which substance is the limiting reagent? So the procedure to decide which one is the limiting reagent, we have to let one as the limiting reagent, and we will follow some steps, and that will decide which one is the limiting reagent. So look now, the quantities of the reactants hydrogen and oxygen are given from the stoichiometry of the equation. First, these two substances, for these two substances we are going to make the moles ratio. So hydrogen and oxygen are involved. So moles of hydrogen to moles of oxygen are 2 to 1. So this will be the first step. We will make the mole ratio. Now the procedure will be start to decide which one is the limiting reagent. Now we will let one substance as the limiting reagent. So look now, let the number of the moles of the oxygen needed to react with all 10 moles of hydrogen be X moles. So now put in the values, because moles of the hydrogen are 10 and we have let the moles of the oxygen as X. So look now, because in the numerator moles of the hydrogen are given and moles of the oxygen are given in denominator, so we will put X in the denominator. From here cross multiply the values, find the value of the X. Now look, X is actually 5, and X we have let the number of the moles of the oxygen. But in question, moles of the oxygen are given 8, and we have come to know that 5 moles, just 5 moles are required to react with 10 moles of the hydrogen. It means still there are some moles of the oxygen available. So it means hydrogen is totally consumed, but some moles of the oxygen are still left. So it means hydrogen is the limiting reagent. So look now, 5. So excess O2 is 8 minus 5, because 8 moles are in total given in the question. So still 3 moles are left. So it means limiting reagent is hydrogen. So this will be the first step. Now, because hydrogen is the limiting reagent, so this substance will actually stop the reaction. So the requirement is now in the second part is how many moles of the water are formed. So actually water will be formed accordingly of the hydrogen, because hydrogen will stop the reaction. So as far as hydrogen will be consumed at all, at that point we have to check what amount of the water is produced. So now we will equate the hydrogen, because that is hydrogen is a limiting reagent, hydrogen with water. So look now from the equation, again hydrogen is 2 and water is also 2. So look now, requirement is how many moles of the water are formed. So this is very easy, I think so, because hydrogen moles are 10. So look now, mole ratio of H2O to moles ratio of the H2 will be 2 to 1, 2 to 2, that will be 1 to 1. So number of the moles of H2O produced, number of the moles of the H2 will be 10 moles, because both are having the 2 moles in the equation. So 2 moles in the equation. So if there are 10 moles of the hydrogen that are consumed, so at the same time, because of this, 10 moles of the water will be produced as well. So this is one method. Okay, and other question we will do through the same method. Hot aluminium reacts with chlorine gas to form aluminium chloride. A mixture of 3 moles of the aluminium and 6 moles of the chlorine are allowed to react. So look now, aluminium and chlorine are going to react. First part is write a balanced equation for the reaction between the aluminium and the chlorine. So look now, you have to write down the balanced equation. So this is, I'm telling you again and again, you must have enough grip to write the equation and then balance it in a minimum time. So this is the balanced equation. So A part is done. B part is which is the limiting reagent. So again, first we will compare the mole ratio of these two substances. So moles of Al to moles of Cl2. Cl2 is 2 to 3. Again, now the process of checking the limiting reagent is going to be started. Let the number of the moles of the Cl2 required to react completely with 3 moles of Al. So look now, 3 moles of Al, and we have let the moles of the chlorine X. So look now putting the values into this, moles of the Al we have let, okay, moles of the Cl2 we have let X, that will be put in denominator, and moles of the aluminium given in the question are 3 will be written in numerator. Cross multiply the values, you will get the answer 4.5. Okay, it means 4.5 moles of the aluminium of the chlorine are enough to react with 3 moles of the aluminium, but in total 6 moles of the chlorine were given. It means still 2.5 moles of the chlorine are left, and all the moles of the aluminium are consumed. So it means aluminium will be limiting reagent because that is fully consumed, but still some moles of the chlorine are left. So this is the first thing. So look now, in these kind of the questions, this is the first thing that is required to check. Now we will compare Al with the product that is in question. So look now, how many grams of the aluminium chloride are formed. So now aluminium and this product will be compared. So this is very easy now, because 2 moles are showing that as many moles of the aluminium are consumed, the same moles of the product will be produced. So aluminium's moles are 3, so it means 3 moles of the product will be consumed, will be formed as well. So look now. Okay, requirement is how many grams? Okay, how many grams of the aluminium? Okay, first we have find the number of the moles. So number of the moles of the product that are formed are 3. Up to this step we are done. So the further process will be very easy because the number of the moles we have find it out. So moles is equal to mass over molar mass. Because mass is the requirement, we will let the mass m. Molar mass, we can find the molar mass of AlCl3 through the through the periodic table, will be put in denominator, will be equal to 3, and from there m will be find it out. Look now, m over molar mass of AlCl3 is 134. So m over 134 will be equal to 3. So look now, this 3 will come here, and then 134 will also become here. So this is very easy because we have find out the number of the moles of the product, that is 3. Now use the formula. Moles is equal to mass over molar mass. Mass is the requirement. Molar mass can be find out by the help of the periodic table, and is equal to 3. So molar mass will be multiplied with 3 to give the mass of the product. So this is done. Okay, here is another question. When a solution containing 3.30 grams of Na3PO4 is mixed with a solution containing 6.60 grams of lead nitrate, a double decomposition takes place to produce lead phosphate and sodium nitrate, right? An equation for the double decomposition. So again, look here. First thing that is required is write the balanced equation. So this is the very important step. So practice a lot, students, because this will be the first step in these kind of questions to write the balanced equation. So this will be the equation now. Second is calculate the mass of the lead phosphate formed. Here is lead phosphate. But first we have to decide which one is the limiting reagent. Look here, now the masses are given. In previous questions, moles were given. So this is very easy. Solve the question with the same method. First, convert these masses into moles because we can find the molar mass of the compound. So the formula used for the finding the number of the moles will be moles is equal to mass over molar mass. So this mass over molar mass will give us the moles of this substance. Likewise, mass over molar mass of this compound will give us the moles of this compound. So now look, moles are given. So now this is the same question as of previous ones. So the same procedure will be adopted. We will let one of the compound substance as the limiting reactant, and we will let that X moles of this will be enough to react with the other. So same procedure will be followed. Try to solve this question at your home. This will be much easier. If you feel any kind of difficulty, my YouTube channel is available. You may send me the question, or you may call me at my mobile number, or you may WhatsApp me as well. Take the pic of the question, solve the question, take the pic of the solution and send it to me. I'll give you the answer, either this one is the right one or not. So again, look, calculate the mass of the lead phosphate is the requirement. First you have to decide which one is the limiting reagent. First you have to take the mole ratio of the two reactants. This will be the first step. Then you have to decide which one is the limiting reagent. That will be the second step. And after deciding the limiting reagent, limiting reagent will be compared with the lead phosphate, because the lead phosphate is the product that is in question now. So whatever the limiting reagent that is decided will be compared with lead phosphate then, and from there the answer will be solved. So again, read the previous questions. That will help you this question because this is the same question. Thank you so much.